Hey there, math lovers. So welcome back to my channel, and I hope you enjoyed my previous video where we tackled a challenging equation of order 4. And there I presented an innovative approach to solve such problems if that's possible. And today we're diving even deeper into the realm of algebraic equations as we take on yet another formidable challenge, and that is solving a difficult equation of order 6. This equation is bound to push the boundaries of our problem-solving skills, and I will introduce to you yet another innovative technique for solving such problems. I had a discussion in my previous video with a user called Moberry, where basically he pointed out that my technique for solving that equation of order 4 was not general, and he went on to present his own approach. And I also replied to his comments. First of all, I really appreciate you guys that you engage with my content. But adding on top of that, I have to say, I never said that actually my techniques are general. Generally, as you know, for equations of order bigger than 4, there is no general formula. And most of the times you have to just resort to some technique. I mean, there are various ways. You can learn from different books, but sometimes you just have to invent one. The most common technique is basically trying to factorize an algebraic expression, but there are also some other techniques. And for example, in my previous video, I taught you how to generally solve an equation of order 4 if they are in this form: x plus b to the power of 4 equals a. And I just told you that the best way would be just to take a new variable, which is w minus basically a plus b over 2, and just replace this variable here inside these parentheses and solve for w. But to reach to this form, well, you have to test if you have a general equation of order 4 to see if you can reach that form. So now we have this equation of order 6. How can we solve this problem? Well, as usual, well, it's very difficult to factorize this problem. I mean, feel free if you can do so. But someone says, well, let us just try some integer, numbers, see if it works. Well, if we put x equals 0, then definitely that is not, what we get is 0 plus 66, which is definitely not 0. But let's just try another one. X equals 1, and that gives me 1 minus 6 plus 5 plus 20 minus 36 plus 16 plus 66, and these guys cancel each other, and these guys also cancel each other, and it gives me, interestingly, 0 plus 66. Okay, that's interesting, because even though it didn't become 0, but it was very similar to x equals 0. And what if I try, I can also try some other values, but what if I try, let's say, x equals 2. Then I get 2 to the power of 6, which is, I think, 64. And what else I get? Minus 6 times 32. Okay, minus 6 times 32. And, well, I think it's going to be a little bit difficult. I'm not going to do that. But my point is, let us just take s to be x to the power of 6 minus 6x to the power of 5 plus 5, just the first part of it, except for the last one, plus 5x4 plus 20x3. And what is the other term? Minus 36 and 16. Okay, minus 36x2 plus 16x. We know already that for this expression, x equals 0 and 1 are two answers. So in order to simplify this, I'm going to just divide this by this factor, x times x minus 1, which is basically x2 minus x. Okay, I will divided by x2 minus x. And in order to just, perform this division, let us just delete that. And what I will get is basically x4. And here is minus x6 plus x5. And let us just do this division. Let's see what we get. Minus 5x5 plus 5x4 plus 20x3 minus 36x2 plus 16x. And then I get minus 5x3. Here it will generate 5x5 minus 5x4. And these guys cancel out each other. And then I am remained by, with this guy. 20x3 minus 36 x2 plus 16x, and then I divide that term again. This is 20x, so this gives me minus 20x3 plus 20x2, and if I just do this operation, then I get minus 16x2 plus 16x, and again one more, and that is minus 16, which basically cancels out this guy, 16x2 minus 13x. Let me check out again. Yeah, that's true. It canceled out everything. And well, it has to cancel out because x2 minus x is basically, a factor for that expression. So in other words, s can be written as x times x minus 1 times the other guy, x4 minus 5x3, x4 minus 5x3, and plus 20x minus 16. Okay, so far so good. And now take a look at this expression. It sounds like it's still factorizable. If I put x equals 1 again in that expression, I get x equals 1. So I get 1 minus 5 plus 20 minus 16, and this is again 0. Interesting. So in other words, there are two factors of x minus 1. So I'm going to just divide that by x minus 1 again. So let us just try something else. Yeah, maybe it works as well. I wanted to try x2 back up here. And it was a little bit more complicated, so it's better to do it here. Maybe it's simpler. So I get 64 minus 5 times 8 plus 40 minus 16. And that is 104. Let me just see. 2 to the power of 4 is, sorry, this must be 16. I made a mistake. So this is 16 minus 5 times 8 plus 40. And these guys cancel out each other. Oh, so then it is also divisible by x minus 2. So now I know that this guy here is divisible by x minus 1 times x minus 2. And I'm just going to divide that guy by this. And just keep in mind that we still have this 66 here, okay? I'm just trying to figure out what I can do with this. So then I get s equals x times x minus 1. Well, before actually doing that, let us just do this division. So x4 minus x5 3 plus 20x minus, I have to delete that, minus 16 divided by this factor, which is basically x2 minus 3x plus 2. And this gives me x2 minus x4 plus 3x 3 minus 2x2, and this gives me, well, this is cancelled, and this guy is minus 2x3 minus 2x2 plus 20x minus 16. And if I divide that again, this is minus 2x and 2x3 minus 6x2 plus 4x, and that is minus 8x2 plus 24x minus 16, which is basically minus 8, and that is 8x2 minus 24x plus 16, and these guys all cancel out each other, well, as expected, because that should be dividable by that factor. So then I get this guy, and that is also dividable, or factorizable, and that is x minus 4 times x minus 2. Interesting. Sorry, x plus 2. Interesting. So the whole s can be written, in other words, s can be written, or let's go back to our equation. We can write x times, that was the first, those were the first factors, x times x minus 1, and then we found two different factors, x minus 1 times x minus 2, okay, minus 2, and then we found these two other factors, x minus 4 times x plus 2, just by trying, x0 and 1, and then just figuring out that, okay, yeah, it works also for 2, and just by simply, yeah, dividing these algebraic expression. Plus 66, this is 0. Okay, this was s, guys. So how can this help me? Well, I don't know. Let us just maybe a little bit sort out these guys next to each other. So if I have x here times, let's say, x minus 2, well, I start from minus 2 here, because, yeah, it sounds like here, if you just pay attention before, so these two guys, let's just say, well, that is x minus 1 to the power of 2, and that generates x2 minus 2x. And if I look at these guys here, if I multiply them, they also generate a term such as x minus 2x. And also these two guys, if I multiply them, or they were already here, they also generate x2 minus 2x. So let us just put them next to each other. Then I get x times x minus 1, which is basically x2 minus 2x. No, sorry. I have to put x times x minus 2. First we sort them, and then I have x minus 1 to the power of 2, and the last one I can just write it as x2 minus 2x minus 8 plus 66. This is equal to 0. And then here I get x2 minus 2x times x2 minus 2x plus 1 times x2 minus 2x minus 8 plus 66. This is equal to 0. So I found out that if I basically look at these factors in the right way, I can create or generate a common factor among all of them, x2 minus 2x. Well, that is very helpful, because now I can just take x2 minus 2x to be a new variable such as t, and then I have t times t plus 1 times t minus 8 plus 66. This is equal to 0. Perfect. Now, instead of solving an equation of order 6, I just have to solve an equation of order 3. And if I just simplify this, then I get t3 minus 7t2 minus 8t plus 66 equals 0. So, yeah, now I have to solve this problem. But this can also be a little bit of experimentation. This can also be solved easily, because if you just try different integers, it turns out actually t equals minus 3 is a factor. You just have to divide this whole expression here by t plus 3. And if we do that, then, well, let's just do it. Let's just divide it by t plus 3. Then I get t2. Then that is minus t3 minus 3t2, and that is basically minus 10t squared minus 8t plus 66, and that is minus 10t here, which gives me 10t squared plus 30t, and that gives me 22t plus 66, and that also gives me 22, which basically cancels out this guy here. Okay, perfect. So I have that factor t plus 3, and then the quotient will be this guy here. But okay, that cannot be factorized further. So then one solution will be t1 equals minus 3, and the other two solutions will be t2 and t3 will be basically 10 plus minus square root of 100 minus 88, which is basically 12. And I can just, instead of 12, I can just write 2 square root of 3 divided by 2, which gives me 5 plus minus square root of 3. And now let's go back to that equation, x2 minus 2x minus t equals 0. That means x equals 2 plus minus a square root of 4 plus 4t divided by 2, which is basically 1 plus minus square root of 1 plus t. Okay, so I have those values for t, and if I just replace them, well, probably I get some, I'm not sure if I get all real numbers, but let's, I think some, yeah, I'm sure that I get some complex roots as well. So for t1 equals minus 3, well, that gives me 1x is basically 1 plus minus I squared root of 2, and then, or sorry, plus, let's say, and 1x would be 1 minus I squared root of 2. And let's go for the other, let's just take t2 to be 5 plus square root of 3, and then x3 will be 1 plus square root of 1 plus t, which is basically 6 plus the square root of 3. And then x4 will be 1 minus, yeah, this guy 6 plus the square root of 3. And then if we take t3 to be 5 minus the square root of 3, like here, then I get 2 more roots, which is basically x5. That is equal to 1 plus, square root of 1 plus t, which is 6 minus square root of 3. And then x6 will be 1 minus square root of 6 minus the square root of 3. So I have 4 real roots and 2 complex roots. So did you like this solution? Well, going back to the equation here we had, so basically we don't have to always factorize the whole thing. It just suggests that maybe if you just start with this part, which is easier to be factorized, and you just do your best, maybe some patterns will show up, and then you can use those patterns and solve these problems. So in the future, if you'll ever be given such equations, you can try this method and see if it can solve the problem. So if you enjoyed solving this challenging equation with me and want to see more math content like this, don't forget to give this video a thumbs up and hit that subscribe button. And by subscribing, you'll stay updated with all the latest math videos on my channel. And together, again, we'll continue to explore the fascinating world of mathematics. We'll tackle difficult problems and we unlock the beauty of mathematics. Thank you for joining me on this incredible math adventure, and I'll see you in the next video.